is Anthony Wu, and today I'll be talking about the analysis of customer data set. I am with Group 13, along with Tyler Downey and Robert Young. To begin with, I want to give a short introduction about the data set. The customer data set was actually pulled from Kaggle, and it is about an unspecified store with 2,000 records, and these records come from membership cards. It has variables such as gender, age, annual income, spending score, profession, work experience, and family size. And the main output that we're going to be looking at for this data set and for our models is spending score, which can range from 1 to 100 and describes how much a specific customer will be spending at their store. So it's a good measure to figure out how much income they can or revenue they can bring to the store. Now, the data set did need to be cleaned up before being put into any models and analysis. The profession field had some missing data, so we had to use XLMiner to delete any of the missing records or missing data and just delete those records. Also, it had some categorical values that were in non-binary format, so it had string variables. So we had to change that to zeros and ones along with creating some dummy variables. Now, the main question we're going to be asking for this data set is how to predict a customer spending score. Before we get into that, I'm going to be talking about the data summary and visualization. To begin with, I'm going to talk about the distribution of professions. This could be very useful to know as a store owner, since if you have more than or a majority of one profession, it will be good to cater your products to that one profession. In this data set, you'll see that the profession artist actually has the most, as at least like members. The next one would be healthcare, and the lowest one would actually be homemaker. So given that of this information, maybe the store owner would like to perhaps have more artistic products such as canvases, paintings, paper, pencils, things of that sort, in order to bring more revenue to the store. The next one we have is spending score by profession. This will also be useful to know by the store owner, since if a profession has a higher spending score, it will also be good to focus on them. Now, as you can see, the range of spending scores between professions isn't actually that high. The lowest one, which is homemaker, is a little bit over 46, while entertainment is a little bit over 52. And the difference between those numbers isn't actually that great. So the store owner shouldn't really be focusing on just one profession if they want to hire or focus on the spending score for the profession. Next, we have average income by member age. The data set here seems to be a bit strange, as they have ages 0 to 12 to be quite high in terms of income, which I don't know if that's just a mistake on the author's part, but I included it in this data set regardless. And as you can see, they're all about the same with jumps ups and downs between ages. There's not one distinct age group, except you can maybe say that ages around 80 to maybe 90 has higher average income in this data set, with about 80 being the highest average income. So now with this information, the store owner can now determine that the average income for all their members' ages are about the same in terms of age groups. But if you did want to focus on one, the age of 80, about 80 is one to focus on. Now I'm going to be talking about the models we use on this data set, which is linear regression and KNN. Before we put any data into our models, we have to first prepare the data. First, we did this by creating dummy variables for gender and profession, since gender had their data as male and female instead of zeros and ones, and profession had them stated out by what profession they were instead of zeros and ones. Also, we had to delete some records that were missing from profession, since missing data can often uh, skew data or analysis in these models. So it's best to just delete them. First, I'm going to explain the linear regression model. It is a statistical base model. It basically uses y equals mx plus b, a linear model. And it's used to fit a relationship between a dependent variable and a set of predictors, or in other words, independent variables. And it needs to have no missing data, and it has to have binary dummy variables. And it's important to note that the dummy variables must have 1 minus the category it needs. For example, for gender, when splitting them up into dummy variables, you have male and female. You only want to pick one of them. So let's say male, and then have that be inputted into the model. Including both male and female will be quite redundant, and it would also create bias in the model itself. Now, the results of the customer dataset for linear regression were quite interesting. Before talking about the results, I want to say that we use 60% training and 40% validation for the data. And the interesting part was that no variables actually had p-values less than 0.05, which means that there wasn't any variables that was statistically significant, which is very odd. I've never seen that in a data set before. So maybe this data set wasn't the best one to use for this project. Now the MSE value, which describes the error rate for linear regression, was 817.48, and the MAD value was 24.48. And the annual income and entertainment profession, as well as the male gender, also were the only variables that had positive coefficients, which means that if you have a higher annual income and if you are in the entertainment profession, it is more likely that you will have a higher spending score. So it might be something worth looking at for a store owner to mainly focus on the entertainment profession in regards to the linear regression results. Now, the KNN model is data-driven and not model-driven. Compared to the linear regression model, it does not rely on a linear model or anything like that. And it just purely finds similar records and training data based on predictor values. So if you give it a point, it will try to find similar records along that point. And depending on the K value, it will try to grab records based on that K value. For example, a K value of 1 will stay very local and only will find a record, the closest records to it. A K value of 10 will find 10 records closest to it before making that determination of predicting data. And another good thing about the KNN model is that it makes no assumptions about data. Now, for the customer data set, the KNN results were that, before getting to the results, actually, we use 60% training and 40% validation as usual. And we use search for K. And when we search for the best K with the lowest error rate, it showed up as K equals 10, which means that the data set did require a lot of smoothing. The MSE value for KNN was 926.98, and the MAD value turned out to be 25.79. Now, when comparing the linear regression versus the KNN results, you'll see that the linear regression did actually have less of an error rate. The linear regression had an MSE value of 817, about, and KNN had a MSE value of 926. So about like 100 difference there. And the linear regression model had a MAD value of about 24.48, and the KNN model had a MAD value of 25.79. Now we can draw conclusions from those results. And that conclusion is that the linear regression is actually a better model to find out how to predict a customer spending score. Because of the lower error rate, you won't find you'll find that the linear regression model is better at predicting. And in general, the linear regression model is better at predicting than classification. The KNN model is generally more used for classification, but I did want to see how KNN compares to a model-driven versus, being a KNN being a data-driven type model. And as I looked at the results of the KNN model, it seemed like the KNN model had trouble building relationships because of the data being so random. It seems like it couldn't figure out the reason for the spending score in terms of looking at other independent variables. And that is the end of this presentation. Thank you so much for watching, and hope you have a great day.